Let's look at Chapter 2, Section 6, Combinations of Functions and Composite Functions. So we're going to look at domain of a function, then combine some functions and specify their domains, then form composite functions, determine the domains of composites, and then write functions as compositions. So first thing we want to look at is finding a function's domain. And the reason we want to do this is so we can find out if there's any restrictions in the x values. So one thing you want to do is make sure that if you have something like a over b, that b is not a zero, does not equal 0. And that's how you can write your exclusions. So anything that would make b a 0 would be excluded. So exclude from a function's domain real numbers that cause division by 0 and real numbers that result in an even root, such as a square root or a negative number. So we'll look at this first function. G of x equals 4 parentheses x minus 2, which if you look at this, it would be 4x minus 8. Let's just say it's y equals. This is just a linear function, slope of 4, y-intercept of negative 8. So if you were to 1, 2, 3, 4, 5, 6, 7, 8, then up 4 over 1, something like that. So it's a straight line, it's linear. So our domain is our x values. It's going to go to negative infinity and positive infinity, from left to right. So that means your domain is going to be negative infinity, positive infinity. Or you can write it as all real numbers, the R with the extra line. The next one, we have 5x over x squared minus 49. So we would need to simplify this or factor it. So g of x equals 5x. So think about this as x squared plus 0x minus 49. This is a difference of squares. So this will factor down to, what's the square root of 49? 7 and negative 7. Square root of x squared is x. So the difference of squares would be, this is a square, this is a square. There's the difference of the squares. We'll look back at this one. And so we would put x plus 7 times x minus 7. And so that's the factoring. So to do our domain, we have to look at if either one of these can be made into 0, because you cannot have 0 as our denominator. So what we'll do is we'll do x plus 7 equals 0 and x minus 7 equals 0. And we want to solve and see what x equals to make it equal 0. So minus 7. So we get x equals negative 7 plus 7. X equals 7. So this means that x cannot equal 7 or negative 7. But it can equal anything else. So the way we're going to write this is domain is negative infinity to positive 7. I mean negative 7. And it doesn't include it, so we're going to put parentheses. And then union with negative 7 to positive 7 with both parentheses because they're not included. Then union 7 to infinity. And what this is there's an asymptote there. So I'm going to graph it and see it. Whenever I have and I go to graph, look how it does. So that trace, the origin 0, 0, but I can go left or right. gets closer and closer to -7. But it's never actually going to touch -7. And then maybe jump over. Oh, there it goes to the other side. Then it goes to -7 on the other side. And if you look on here at -7, it's going to say error. And then +7, it'll say error. So those are where it's restricted. So that's how you can look at it on the calculator. Okay, let's move to the next page. Okay, so from the domain of this is a quadratic function, x squared minus 3x minus 11. There's no restrictions there. If you look at it in the calculator, x squared minus 3x minus 11, it's just quadratic. You do something like this. Left, negative infinity, right to infinity. So it's all real numbers. There's no restrictions. Domain, negative infinity to infinity. Or all real numbers. In the next one, though, we have some denominators, some fractions. So we have to find out when this equals 0 and when this equals 0. Anytime you get it equal to 0, then it's restricted. You can't. So x minus 2 equals 0, x plus 3 equals 0, plus 2 plus 2, x equals 2, minus 3, x equals 3. So what this means is we don't want it to equal 0. So it's actually x cannot equal 0. I mean, cannot equal 2 because that would make the denominator 0, and x cannot equal -3. We're going to do this similar to that other problem that we did. We pick our smallest number. So it's going to go negative infinity to -3, -3 to 2, and 2 to infinity. You want to go from least to greatest. And negative infinity is the smallest. So negative infinity to -3 union, -3 to 2 union, 2 to infinity. Another thing that causes some restrictions is if you have a square root, this cannot equal anything less than 0. Less, I guess it could equal 0, so let's say just less than. So if we're going to look here, what's the square root of 0? Does that cause problems? Square root 0 minus 0. Yeah, that causes problems. So if it gives you an error, that's how you can find out if it causes problems. So the square root of x minus 6 has to be greater than or equal to 0. We wouldn't actually use the square root there. I should not have included that. Sorry. So we're just looking at where x minus 6 is greater than or equal to 0. That's how we want it to be. Plus 6. So x has to be greater than or equal to 6. So the only values for the domain are from 6 to infinity. Infinity is always parentheses. 6 will have a bracket because it's or equal to. And whenever you look at it in the calculator, whenever we go to y equals, and we put in our function for the graph, see how it starts at 6? If I hit trace, it's, it has nothing yet. Let's go to table. There we go. We have errors all the way up till 6. So domain has to be 6 to infinity. Nothing before that. 5 doesn't work, 4 doesn't work. Um, let's see the next one. The domain. So we actually have two restrictions that we're going to deal with. We're going to deal with this being not equal to 0. And then this, we have to worry about the x minus 2 being greater than or equal to 0. So solve it out. So those are our two. So 5 is not included. So let's go least to greatest. It has to be greater than or equal to 2. So domain is going to start at 2 and go to up to 5. Forgot to put the line through there because it does not equal it. And then union that with 5 to infinity. So whenever we have these parentheses here, that means that 5 is not included, but it goes up until 5, not including 5. Okay, let's get to our next problem. So we're going to use domain and restrictions whenever we do our different kinds of products and combining functions. So we have sum and difference. So sum, we're just going to add on. Difference, we're going to subtract on. Product, multiply on. Quotient, divide them. So it says we're going to f plus g of x. So this is the sum. This just means f of x plus g of x. So this is x minus 5 plus x squared minus 1. So we're just going to add them. We want to do it in greatest to least exponent. So it's going to be x squared is first, plus x. And then we have negative 5 and negative 1, making that negative 6. And so it says find the domain in the range. Well, domain of this is all real numbers. Infinity, positive infinity, it's linear. This is quadratic, no restrictions, that's all real numbers. And this is quadratic as well. So our domain for our composite is going to be like B, F, union DG. It's going to be negative infinity to infinity. It's just quadratic, so it's going to be all real numbers. Now let's combine the next one. X minus 5 and then x squared minus 1. We're going to subtract them. So, oh, I guess that should have been a G. Made a mistake there. So x minus 5 minus x squared minus 1. So it's important to use parentheses for the subtraction step. So what this really means is I have negative 1 here that I have to distribute. So what it's doing, this minus, is going to change the sign of everything. So we have x minus 5 minus 1x squared, or just minus x squared. Negative 1 times a negative 1. So we will write them in greatest least order. It's a negative x squared plus x. And then we have a negative 5 and a positive 1, making that a minus 4. It's another quadratic, nothing we have to do there. F minus g, domain of f minus g. These are all real numbers, negative infinity, positive. Next one, we have these two functions that should be g. So this is a multiplying one. So x minus 5 times x squared minus 1. So I'm going to use the box method. X squared times x cubed. X squared times a negative 5x squared. X squared times an x, negative 1 times x, negative x, negative 1x. Negative 1 times a negative 5 is positive. Then I add them up. Nothing can be combined. They're all different. You can put a 1 here if you want. This is polynomial, trinomial. No, it's the third power cubed. But it's domain. There's no restrictions there. So the only time we have restrictions is with square roots or with denominators. All right, let's do the next one. This one is the quotient. We're going to do x minus 5 over x squared minus 1. This is a difference of squares, so recognizing that's important. We have a perfect square here, and 1 is also a perfect square. X minus 5. This is difference of squares. X plus 1, x minus 1. So the only thing that we want to look at is when these equal 0, and that's what we will restrict it. Cannot equal 0, and x minus 1 cannot equal 0. Minus 1, minus 1. Cannot equal positive 1. There you go, least to greatest. So negative infinity all the way up to negative 1. Union that with negative 1 to positive 1. Then union that with 1 to infinity. The next topic is the composition. Sometimes you see it as F. It looks like an O, G. So fog and golf is how you're going to see this. Fog, and you're going to see golf. This is composite functions. You're learning this in algebra 2. So what you're doing is you're inputting a function in for x instead of a value. So the domain of f, composite G, is the set of x that's in the domain of G. G of x is in the domain of f. So we are going to plug in a function in for x. So instead of saying f of x, we're saying f of g of x. Alright, so let's do some examples of that. Alright, so fog means f of g of x. So in the f function, I'm going to plug this in for x. I'm using this function. I'm using this to plug in. So it's going to be 5 2x squared minus x minus 1. Distribute 5 times 2x squared minus 5x minus 5 and carry down the plus 6. So the reason why we multiplied 5 times that was because it was 5x. So instead of x, I'm plugging in g of x for x. Then we combine like terms where we can. Let's see those two. So 10x squared minus 5x plus 1. This is quadratic. There's no restrictions. It's just going left to right. The domain is negative infinity to positive infinity. So this is fog, f of g of x. So the next one, f of x, g of x. We're doing the opposite way. So now we're going to use this and plug this in every time we see an x. So it's going to be 2 and then 5x plus 6 squared minus x, well, x is 5x plus 6. And the last part is minus 1. So on this, we're going to do that squared first. We can use I'm going to do it like this. The box, that's 5x plus 6, 5x plus 6, 25x squared, 30x, 30x, 30. I do want to go ahead and combine these. So it's still 2, because we got to carry that down. We have 25x squared, 30x and 30x makes 60x plus 76. Okay, and then the next part, this is like a negative 1 that has to be distributed. So it'd be minus 5x minus 6, and then carry down the minus 1. All right, we still got to keep on simplifying, so we need to distribute the 2. That's 50x squared plus 120x plus 72. And then carry down everything else. Minus 5x. Oh, go ahead and combine that. Minus 7. And then we need to see if we can combine like terms. There's no other x squared, so 50x squared. And then I have a positive 20x and a minus 5x. So 120 minus 5 is 115. And then 72 minus 7 plus 65. It's really big though. But there are no restrictions on the domain, no square roots. So we can go ahead and just write it as negative infinity to positive infinity. Okay, let's do the next one. F of g of 0. So that means it's f of g of 0. So I need to find out what g of 0 is first. I'm going to look here. I'm going to plug in a 0. And then I will substitute that in. So 2 times 0 squared minus 0 minus 1 times a 0 minus a 0. So g of 0 is just negative 1. So that means I'm going to do f of negative 1. So everywhere I see an x, I'm going to sub in negative 1. So that equals a positive 1. So f of g of 0 equals positive 1. There's no restrictions on any of this, so our domain is just negative infinity, positive infinity. Go ahead and do the next one and pause it so you can do that one, and I'm going to show you the answer. Give you a minute to work on it. So go ahead and pause the video right now. Work on this problem. Okay, so you should have gotten this answer. Plugged in the number, simplified, and then our domain has no restrictions. Okay, let's keep on going. Look at when the values are excluded. The following values must be excluded from the input x. X is not in the domain of g. It must not be in the domain of f of g. Okay, so let's look. We first need to find out what x cannot be. For the f of g, x cannot be negative 2. For g of x, x cannot be 0. So the domain of g, x cannot be 0. So for fog, it says if X is on the domain G, it must not be in the domain of f of G. Any X that is not included in G of X is not in the domain of F, must not be in the domain. Okay. So we need to just focus on this one. Now we're going to do fog, f of G of X. So we would do 4 over 1 over X, because this is what I'm plugging in for X plus 2. Well, I need to simplify that. You know, we all love fractions. But we would want a denominator of X. This is over 1 right now. So we would multiply top and bottom by X. So we have 4 over 1 over X plus 2X over X. And what we could do is we could multiply everything times X, top and bottom, to get rid of our denominator. Because it's just like multiplying times 1. If I multiply times X over X, it's 1. So this is going to cancel out. And I'm going to get 4X over 1 plus 2X. So what I did to get rid of these fractions on the denominator was first I needed to find a common denominator. So that was X. And then I have the common denominator X. I'm going to get rid of that by multiplying by the denominator on the bottom and on the top. And so that leaves me with 4X. And then all these X's on the denominators cancel. It's just 1 plus 2X. So this is my f of G of X, or fog. So then you would want to see, we'd want to look at this and make sure there's no restrictions for X here. So we do 1 plus 2X cannot equal 0. So we're going to subtract 1, solve this simple equation out. Divide by 2. Oh, this is not equal. So X cannot equal negative half. So that's another domain restriction. So these are our 2 restrictions. So remember, you go least to greatest. So we'll start with of f of G. It's going to go negative infinity to negative half, union, negative half to 0, union, 0 to infinity. And that's our domain. All right, that is it for this section.